Hi, welcome back to my YouTube channel. In this particular video, we're going to learn how to find the coefficient of any term in a binomial expansion without actually expanding, the terms. Okay, so in this particular, let's make this one raised to power 10, right? Just to give us a feeling of how to approach this. Let's make this one raised to power 15. Okay, so let's get started. Now, if you're not familiar with binomial expansion, we already said this is the expansion of this type of expression, which gives us n combination 0, x raised to power n, y raised to power 0. Then we continue this way, right? All the way to the last one, which is n combination n, x raised to power 0, y raised to power n. Now, I want you to notice this, that simply in a simpler term, we can write this x raised to power r, y raised to power n minus r. Each term in this expansion can be written this way, right? Where r moves from 0 all the way to n, right? So in this case, for this particular one, this is I just wrote it the opposite of this. So basically, it is this way. Okay. So for example, when r is 0, I would get n combination 0, x raised to power n minus 0, which is n, y raised to power 0. Plus, when r is 1, this is what the sigma notation means. This sigma means addition, right? As we plug in r from 0 up to n in this particular expression. So when r is 1, I'll have n combination 1. So r is 1, n combination 1. I'll have x raised to power n minus 1, y raised to power 1. You can see it happens until the last one when r is n, which is n combination n, x raised to power n minus n, y raised to power n. You can see this gives us 0. This will give us 0, which is exactly what we have here. So this is the general way of writing this binomial expansion. Now, we are not going to expand the whole thing. We're just going to look for the right. See, notice that depending on what r is, depending on what value we give r, we can find any term of this expansion. Okay. So for example, when r is 0, we find the first one. When r is n, when r is equal to n, we'll find the last one, right? So this is the trick we are going to use to find the coefficient of x raised to power 4 in the expansion of each of these terms, of these expressions. So let's start with the first one, raised to power 5. Okay. Now we note that any term in this expansion can be written as what? N combination r, the first term raised to power what? N minus r, the last term raised to power r. This is how, so this would be the expansion, right? This is what we talked about, right? So any term can be written in this form. Okay, so now what we need to do is, don't forget that what, in this case, your n is 5. So that would be r raised to power 0, r from 0 to 5, 5 combination r, 3x, 5 minus r, 2y raised to power r. Now, let's just think a little bit. At what point are we going to have x raised to power 4, right, in this expansion? So let's just isolate each term. So the expression inside, let's isolate this. So for what value of r will we have x raised to power 4? Notice that what we are going to have x raised to power 4 if this is equal to 4, right? If that is equal to 4, then that would mean that what 3x all raised to power 4 would give us x raised to power 4 in the expansion. Okay, so what we're going to do is what we're going to equate this to what? 4, which means our r must be equal to 1. So the time that the term that would have x raised to power 4 is the term that has is the term when r is equal to 1. So r is equal to 1. So what does that mean? 5 combination 1, 3x raised to power 4 because r is 1, and then 2y raised to power 1. In fact, this problem should have asked the expansion of what? X raised to power 4 for this particular one, I think let's just modify this x raised to power 4, y raised to power 1, right? Okay, so what would that give us? That would now give us 5 combination 1, which is actually 5. Then expand this one, that is times 3 raised to power 4, x raised to power 4, times 2 times y. So what we'll have is 2 times 5 is 10, times this is 81, 3 raised to power 4 is 81, then x raised to power 4y. So 210 x raised to power 4y. So that term that would have x raised to power 4 would have the coefficient 810. So the coefficient of x raised to power 4y is 810. So there's a problem in the question. There is no, it's not just x raised to power 4, it's x raised to power 4y for this particular problem. Okay, so this is how we approach it, and this is how we find the coefficient of any term in the expansion. Now we can use the same trick to get the second problem, 1 minus 5x raised to power 10. So the second one, 1 minus 5x all raised to power 10. Okay, how do we find the coefficient of x raised to power 4 here? So we note that what each term in the expansion can be written as 10 combination r, the first term raised to power 10 minus r, the second term raised to power what? R. Don't forget. Now, for what value of r will we have x raised to power 4? That is basically when r is 4, right? So when r is equal to 4, here, it means the power here must be equal to 4. So that means r must be equal to 4, okay? So if r is equal to 4, what does that give us? 10 combination 4, 1 raised to power 10 minus 4, which is 6, then minus 5x raised to power 4. Now, when we expand this, this gives us 1 raised to power 6 is 1 times minus 5 raised to power 4, x raised to power 4. So that means the coefficient of x raised to power 4 is just this one. So the coefficient of x raised to power 4 is 10 combination 4, whatever that is, then minus 5 raised to power 4, which is 25 times 25, which is 625 times 625. Okay, so we can find 10 combination 4, which is 10 factorial, 6 factorial 4. It's actually a big number, times 7 all over 4 times 6. So this will give us 2, 3. This will give us 3. So it's 210, right? So the answer is 210 times 625. Okay, for this particular problem. Now let's look at the last one. Let's look at the last problem. So the last problem is 1 minus x over 2 raised to power 15. Okay, so the C part is 1 minus x over 2 raised to power 15. We want to find the coefficient of x raised to power 4. So again, each term can be written as what? 15 combination r. The first term raised to power 15 minus r. The second term raised to power what? R. So for us to have x raised to power 4, r must be equal to 4 again. So we have 15 combination 4, 1 raised to power 15 minus 4, which is 11, then minus x over 2 raised to power 4. So what does this give us? 15 combination 4 times 1 times x raised to power 4 over 2 raised to power 4, right? Because this minus, because we have even power, the minus will disappear, it becomes plus. If we multiply minus even times, it's going to give us plus, right? So this basically gives us 15 combination 4 divided by 16, right? 2 raised to power 4 is 16. So the coefficient of x raised to power 4 is this, okay? So the coefficient of x raised to power 4 is 15 combination 4, whatever that is, over 16. You can use a calculator to give you the value of 15 combination 4, okay? Or you can do it this way. So whatever, for 15 minus 4, which is 11 factorial times 4 factorial. So if you can do this calculation, all over 4 times 6, right? This is 2, this is 2, this is 7. So if you can do 15 times 7 times 13, this value is 15 combination 4. So basically we have 15 times 7 times 13 over 16. This will be the coefficient of x raised to power 4. All right, so that solves the problems, and I hope you can apply this to any other problem that you have just try yourself, just give yourself some examples and just try your hands on more problems of this nature. So thank you for staying to the end of this video. If you haven't subscribed, make sure you subscribe right now and click the bell button so that you'll be the first to know anytime I upload a new video. And I'll see you guys in the next one.